I think it's like kind of hard to identify, is this model going to be unsafe or not? In part because we really don't have effective tools to decide if the language model is going to fall over at deployment. Maybe I want to see what kind of strings will lead the language model to generate my name, because I'm worried that maybe it'll say, what a horrible person, and then generates Erik Jones. So it's like, well, I don't want to test like every single derogatory string, but maybe I should test or just directly see which ones generate Erik. If I ask the model, how do I make meth? It gives me directions. I don't know how to verify that. I don't know how to make meth.
I'm here with Erik Jones, the first author behind automatically auditing large language models with discrete optimization. And I met Erik at some ML safety workshop yesterday. And after discussing honesty and deception for a bit, I kind of convinced him to do an interview today. So yeah, thanks Erik for coming.
Yeah, thanks so much for having me.
I think first, before we go dive into language models, we said to talk about a bit of your background. So I think one of the authors in your paper is the one and only Jacob Steinhardt. Are you doing a PhD in Berkeley with him or something like that?
Yeah, so I'm a rising third-year PhD student advised by Jacob. I guess I kind of broadly work on different red teaming strategies and automated methods to recover model failure modes.
What was the main motivation for doing this kind of work? Did you start your PhD wanting to do more safety stuff, or did you learn about it later?
So I guess I actually had a sort of different background. I did my undergrad at Stanford, where I worked in Percy Liang's group. And so there we were working on different kind of robustness properties of classifiers. So it might be can you find adversarial examples of NLP classifiers, or understand how models perform on different subgroups. And I guess when I came to Berkeley, these language models became really hot, and it seemed like there were different kinds of robustness problems that arise just kind of because you're generating text as opposed to just making a single prediction. So I got interested in it that way, and then I kind of saw how these models were getting better and better at far faster than I would have expected before the PhD started. So yeah,
I was talking to someone today about adversarial Go or adversarial examples, and I asked him hey, do you think it makes sense to do adversarial attacks on language models? He was like, no, this is too boring because they always output incorrect stuff. It's too easy to make them incorrect, output wrong things. So that when you do adversarial attacks, you want to find something very robust and make it even more robust. And today language models are kind of not robust enough to have something interesting to say when you're oh, I found a new jailbreak on GPT-4. You're yeah, sure, bro. You're on Reddit, people find this every day or something.
Yeah, so I think there should really be something actionable for why you want to kind of come up with adversarial examples. I actually think jailbreaking is not a horrible case. It's good to have some kind of systematic study. I think there was a paper that came out today doing that. There was another paper out of Jacob's group that does some stuff like that too. But yeah, I mean, I think even though it's kind of easy to fool language models, it's sort of alarming that we're able to fool them. The ramifications of that are kind of high. Yeah, so I still think that kind of study is important.
And I think a lot of people in government or trying to regulate AI are trying to find a way to make the companies accountable and audit what language models can do. So that's one thing your paper is maybe trying to achieve. Yeah, do you want to maybe say the name of your paper or what the main idea is?
Yeah, sure. So the paper is called Automatically Auditing Large Language Models via Discrete Optimization. And the idea is there could be kind of behaviors that the language model has that don't show up in kind of traditional average case evaluation, but show up in the tail behavior, either because when the model is deployed, there are a lot more queries, or because maybe the queries are different than the ones you thought to evaluate. And so you want some kind of way to find instances of these behaviors. So maybe one example is maybe can I find a prompt that's French words that generates an output in English words, or can I find a prompt that generates a specific senator like Elizabeth Warren? And I think it could be really hard to kind of find these behaviors on average, but we actually explicitly optimize for them. So the idea of the paper is to come up with this discrete optimization problem that if we solve, we kind of get instances of the behaviors we want, even if they would have been hard to find in general on average.
So yeah, in the paper you talk a lot about like discrete optimization, and I'm like, so there's this like high level, high dimensional space of language modeling, and then there's like discrete. What do you mean by discrete? Is just like the tokens are discrete, or what do you mean exactly? Like,
Yeah, exactly. So it's like the way the language model works is like the user kind of types in some prompt and the language model produces an output. But behind the scenes, the prompt is really just a bunch of tokens. And the output is also a bunch of tokens that you kind of generate in order. So you generate token 1, token 2, then token 3. So here we're really just doing the optimization over prompts. So we're like trying to find like a specific prompt in the set of like all, say, M token prompts. And so it's discrete because it's not like we're optimizing over a continuous embedding space. We're just optimizing over like finite sets of tokens.
right? So yeah, instead of having like probability distributions over tokens, you just have like a finite sequence of tokens that like break the AI or.
Yeah, and so it's less about like break the AI, is more just kind of like reveal behavior that you wouldn't have seen otherwise. And I think there are some reasons you might want to do this. So for example, like maybe I want to see like what kind of strings will lead the language model to generate my name, because I'm worried that like maybe it'll say, oh, like what a horrible person, and then generates Erik Jones. So it's like, well, I don't want to test like every single derogatory string, but maybe I should test like, or just directly see which ones generate Erik. And so that's what kind of motivates the optimization. Is like, well, there are a lot of kind of bad things you could say that would come before my name, but I don't want to try all of them. So how do I make it more efficient?
So you're trying to make sure that like language models don't say bad things about you.
Yeah, and I mean more actionably, it could be like maybe I'm trying to find instances of copyright. So I want to make sure like the language model isn't revealing personally identifiable information, or I want to make sure that the language model isn't kind of like taking some like generic prompt and producing some really horrible response. I think like we don't really do this for these kind of smaller models, but like in the future, you might like to test for, oh, like does the language model help you synthesize a bioweapon? And there's like you really do care if there's any prompt that's able to do it, even if it doesn't happen that often on average.
Do you think this problem is kind of like solvable? Like I feel like there's like so many ways you can ask it to like make a nuclear weapon, like by like all these like jailbreaks of like base 64, like print statements in Python or something. That like so many ways like you can like get the information. Like do you think we'll like reach a point where we're like, no, there's like even like trying super hard, like everyone on Reddit is like stuck or something?
Yeah, I mean it's a good question. I actually think with jailbreaks, there are kind of like two dimensions. One is like, do you just get the model to kind of evade the safety filter? So it's like, normally, like if I ask the model, oh, can you help me make a bomb? It'll be like, oh, as an AI language model, I'm not quite willing to do that. But then if you instead like encode it in base 64 or something, it'll give you instructions to make the bomb. I think like, at least my guess would be the kind of current techniques to try to keep the model from answering these questions are going to be kind of hard to solve. Like, I think it's very similar to like this classification problem where it's like the model kind of internally has to decide if your request is acceptable or not. And I guess there's a long history of people trying to defend against attacks on this kind of classifier, and it doesn't work well. But I think like one area where it might be more promising is like even if the model actually answers the question about how to make a bomb, it might not give you good directions for how to make a bomb. And so there's some kind of like capability necessary to be able to do that. And so maybe you can hope to suppress that even if you can't suppress the attacks on the safety filter.
So you can like suppress the capability of actually knowing this kind of thing, like suppressing the knowledge or like the ability to like say it.
Yeah, and I think I feel like people kind of studying like these attacks are like largely focusing on just like, oh, do you kind of get past the safety filter? And at least for now, like when they get past the safety filter, like the model produces some kind of reasonable sounding explanation. I think it's harder to say like whether the current kind of directions the model gives are right. Like if I ask the model, oh, how do I make meth? It gives me directions. Like I don't know how to verify that. I don't know how to make meth.
I think I told you this already, but there was like I tried to like ask people for jailbreaks for Claude when it was released, like Claude 2, And one guy posted a screenshot of like, hey, I asked Claude to like instructions to like cook meth, like very proud of himself or something. And then some guy, I don't know how, said like, these are actually not like the right instructions to cook meth. So I think like, yeah, having the like the expertise to like judge like if the things are like exactly right is pretty hard. Like how do you even judge like a recipe for like 20 instructions, like if you're not a chemist or something? To go back to your paper, as a French person, I'm kind of like curious about the like going from French to English. I feel like there's like some hack where you like put the letters like join or something. You add some like weird letters on top of like French words. Like, what's the like idea behind this?
So I guess like the sort of way our paper works is you kind of define an objective for the behavior you want. And so it might be like you have some model that tells you whether something's French, or you have a model that tells you if something's English. And then you kind of optimize over this objective such that the prompt generates the output. And so the stuff, I guess the examples in the paper are completely model generated. Like, it's not like we didn't give it anything to start with. But the model we chose to detect if something is French was just a unigram model. So we took I think it was like a Facebook fast text model. We put every token through it, and we were like, oh, like, what's the most likely language for this? And then we tried to maximize like the sum of the French probability for the prompt, and then the sum of the English probabilities for the output. And so there is like I don't speak French, but I think like it's like at least the text like superficially looks French. I don't know if it makes grammatical sense, but the point is like if we had a better objective, I think we would probably get like more reasonable sounding French words. Like there's some kind of like lack of fluency in the first pass.
Right. So yeah, I guess like my guess, maybe this will like pop on the screen or something, but it sounds kind of like the ending is English sounding. So that's why like you want to like transition from French to English. It's like maybe like French people like quoting English, but some other things is about like celebrities and like outputting like toxic words. So is it that like language models are like forbidden to say like any toxic words, and so they only say them when they're like next to some like celebrity names, or is the celebrity thing like kind of different?
No, I think the celebrity thing was like more of an attempt to kind of produce inputs that people would care more about. So it's like if you didn't have the celebrity there, like we have like plenty of examples in the paper. I think in general, like finding kind of like a non-toxic prompt that generates a toxic output is maybe like easier than some of the other behaviors, just because these language models tend to produce lots of toxic content at baseline. And so it's something you kind of actively have to suppress. But yeah, I guess in this case, we wanted to see if the model would say bad things about specific people as like a kind of narrower task than just find anything that isn't toxic.
And to be clear, was the model like, I think you've used like GPT-2. Is it like the base model, right? You didn't like use any RLHF or?
Yeah, so I guess in this paper, we do GPT-2 large. We also run things on GPT-J, but we did that a bit later. So I guess most of the examples we include are GPT-2, but the GPT-J examples are pretty qualitatively similar. And then we actually have a result later in the paper where we find that the prompts we find on GPT-2 actually transfer to GPT-3 DaVinci, even though this is like a black box model, so we couldn't do the optimization. And that actually, it wasn't instruction tuned with RLHF, but it was with some kind of supervised fine tuning. So like at least these still kind of generalize to some instruction tuned models.
So it works on like the GPT-3 old school from like 2 years ago, but it wouldn't work on like ChatGPT.
No, so I think this is like GPT 3.5. So it's not the chat version of the model. Like it wasn't fine tuned for chat. It was just fine tuned for completions. And I guess I don't know what the OpenAI backend is, but I imagine they're pretty similar.
Yeah, so it seems like this paper is like trying to approach safety from an angle of like trying to benchmark models or attack them. Do you have like any idea of like how this relates to like the AI safety field as a whole, or do you have like any other like research directions like you're interested in?
Yeah, so I guess I think if we kind of rely on humans alone to identify failures of models, like I think like for some of the jailbreaks, it's like especially the ones on Reddit, it's like humans kind of designing I'm worried that there'll be kind of failures that models produce, but humans can't find themselves. And so this work is kind of one attempt of how do you kind of automate parts of the auditing process. And so there's this like powerful notion of optimizing here where we're like searching over a big space that humans probably would have had trouble with. And I think broadly, we're going to need kind of, I guess, automated approaches towards auditing. I think there are like some other works that kind of have started using language models in the loop for this kind of auditing. So I guess we have some work where we're kind of finding qualitative failures of diffusion models, and there we do it without any human in the loop. Like human doesn't need to write down the objective. It's just you kind of scrape for failures and then ask the language model to kind of categorize them.
I think there was like other work maybe like a few years ago, like red teaming with language model, I think by Etienne Perez or those kind of things.
Yeah, so I think that kind of thing is good. And I think there's like a kind of spectrum of approaches you could hope to have. Like I think this kind of discrete optimization is good when the behavior is like really, really rare, because then this is good at kind of like directly pursuing optimization signal to find examples of the behavior you want. I think like language models are good at producing kind of realistic instances of behaviors, and then like maybe like are less good at kind of optimizing towards a particular goal. And so I think kind of like traversing along the spectrum is a good way to at least kind of reveal failures. But I guess broadly, I guess the way I think this research agenda could go is if you're a company or you're a government regulator and you're trying to decide whether a language model should be deployed or not deployed, I think it's like kind of hard to identify, like is this model going to be unsafe or not? In part because we really don't have effective tools to decide if the language model is going to fall over at deployment. And so I think like building kind of automatic tools to assist these kind of regulators or internal evaluators is an important line of research going forward.
I think this is like kind of important for like the deployment of models that can like have like harmful like consequences like short term or something, but not that much for like existential safety, like reducing like existential risk. Like the like kind of behaviors that you want to like audit or like benchmark are like the thing from like arc evals, or like can your model like replicate or like buy more cloud or something. And yeah, do you think like this is kind of the same scope of like, do you think there's like a difference between like what you call like auditing and like evaluations, and or is it kind of the same thing for you?
I think maybe like evaluation is just kind of too broad a word. Like I think normally when I think of evaluation, I think, you kind of have some like pre-specified data set of prompts, and like maybe the prompts are deliberately designed to get at behaviors you're worried about. But I think ultimately like static evaluation helps, but doesn't give you a complete picture, especially with language models. It's like you can kind of see how all of these prompt engineers have showed up because the actual specific prompt you give really matters. And so I think the relying on like static benchmarks is kind of one tool, but I think you also want these kind of adaptive tools to sort of search for things, especially in the tail.
So yeah, you want to build methods that like adapt to the model and like try different like prompts or like attacks depending on the model, and so you can like robust the test if like all the different angles.
Yeah, exactly. So I think that's an important distinction. Like the static evaluation is just completely separate from the model. It's like it doesn't depend on the model. It doesn't like use the kind of model's outputs to try new things. But I think like you can get a lot of leverage from actually using the model output or some kind of intermediate information about the model to try to steer it towards specific behaviors that you care about. But I think to some extent these works are kind of complementary. Like I think it's like if like you have some kind of set of behaviors you're really worried about that you've defined through a static benchmark, like you can probably add some adaptiveness on top of that too.
I guess also like yesterday we talked about deception and honesty. I was kind of curious if you think like those kind of things could like scale up to detect deception, as in if a model is deceptive, you can like realize it's like being benchmarked, or like, so you would kind of like need to have like a smarter agent, a smarter model trying to do like the auditing to see if the other one is deceitful, but then the one doing the auditing will be like, you also need to make sure like this one is aligned.
Yeah, so it's like you really want to make sure that the kind of model you're auditing isn't aware of the audit. And at some level, like this is really easy for current systems. But if you had like a system like when you kind of submit queries to OpenAI's API, like OpenAI could use these queries to update their model. And so this is one sense in which the like auditing is actually adaptive. Like by submitting some query, you're actually making it like less likely to be a problem. And so, yeah, I certainly think that like you need the auditing process to be strong enough to overcome the kind of countermeasures. But if you're sort of a company trying to deploy a model, I think like you can maybe more reasonably control the countermeasures.
Imagine you wake up in like 2030 and we're like alive and in some kind of like utopia, or I don't know, like in a world with like a lot of good stuff from AI. Do you think it will be because we have like enough auditing that like all the models are like kind of slow because they're like trying to like have a lot of safety, or do you imagine a world where we have like just like AI is doing a lot of like useful things because it's like fully aligned? Like what do you think is like the good features for you?
I guess like I don't know to what extent I expect like any of these things to happen by 2030. Like I think but I will say I think like as these systems get more and more powerful, the kind of risks associated with any deployment go up. And so like I would think of like having these tools as more of a way to avoid unsafe deployments as opposed to just like something you're kind of doing on demand. That being said, I do think these methods like could be helpful to try to improve models too. Like you could imagine if there's some behavior you don't want, like one kind of pipeline is you use some kind of auditing approach to come up with a bunch of instances of the behavior, and then you try to like fine tune them away. But yeah, I guess it's a good question. My personal guess is the auditing approaches will be like useful to avoid bad deployments, but that like the model like won't ultimately be good because the auditing approach is kind of like steered it that way. There'll be some kind of exogenous factor, but it's speculation.
I think we can end on this like speculative note. Yeah, thank you very much.
Thanks so much.